Explaining boiling and evaporation using kinetic theory. Hello students. In the last lesson, you learned the assumptions of kinetic theory and used them to explain the states of matter, that is, solid, liquid, and the gaseous states. In this lesson, we shall use kinetic theory to explain some common phenomena like boiling and evaporation of liquids. Recall that, with respect to gases, kinetic theory assumes or states that 1. A small volume of gas in a container has numerous molecules moving in random directions. 2. The moving molecules hit the wall of the container, exerting force, that is, pressure. They also hit one another without losing energy. These assumptions help in explaining some phenomena such as boiling, evaporation, and solidification of liquids. Using kinetic theory to explain boiling and evaporation. Boiling is the change of state from liquid to gaseous state. The temperature at which water or any liquid begins to boil, it's called its boiling point. Water boils at 100 degrees Celsius. Evaporation is also a process involving change from liquid to gaseous state. It is, however, different from boiling in that evaporation can take place at any temperature. Boiling takes place only when the liquid has reached its boiling point. Note that a liquid evaporates faster at a higher temperature. Now, students, look at the picture of boiling water again. What do you observe? And how can we explain boiling using kinetic theory? Boiling takes place when the average motion of particles is fast enough to overcome the forces holding them closely together. Boiling takes place evenly throughout a boiling liquid because the temperature is uniform throughout. Evaporation, however, takes place only at the surface of the liquid at any temperature. Both cold and warm liquids can evaporate. Both boiling and evaporation occur because some molecules have acquired sufficient energy to break away from the binding force of attraction. Fast-moving molecules are far away from other molecules. Thus, the force binding them is weaker. To break the bond between two particles, one particle has to be moving fast enough to overcome the pull of the other until it gets so far away that the pull is diminished. Differences between boiling and evaporation. Boiling occurs at a fixed temperature, while evaporation occurs at any temperature. Boiling occurs throughout the liquid, while evaporation occurs only at the surface of the liquid. And while boiling occurs quickly, evaporation occurs slowly. And lastly, in boiling, bubbles are formed in the liquid, while in evaporation, no bubbles are formed in the liquid.